Hi, welcome back. Today we are going to talk about linear inequalities in two variables. And remember that inequalities use less than, greater than, less than or equal to, and greater than or equal to. Remember that if it is less than or greater than, it does not include the solution. If it is less than or greater or equal to, or greater than or equal to, then yes, the number is part of the solution plus whatever direction you need to go. So we're going to graph linear inequalities using less than or equal to or greater than or equal to. In a linear inequality in two variables, it can be written in one of the following forms, and you'll notice it looks a lot like standard form. So we've got ax plus by is less than c. We have ax plus by is less than or equal to c, ax plus by is greater than or equal to c, or ax plus by is greater than c. In this case, a, b, and c are all constants, and a and b cannot both be 0. The solution of an inequality in two variables is one or more ordered pairs that make the inequality true. And this is a little different because when we were talking about inequalities earlier in the year, we talked about one variable. This one's going to have two variables. So in this case, ordered pairs are going to make the inequality true or not true. Because there's going to be an x value and a y value. There's where the two variables come in. So it says some students at a music recital perform 3-minute pieces and some perform 5-minute pieces. The total time of this part of the recital needs to be at least 30 minutes long. An inequality that represents this is 3x plus 5y is greater than or equal to 30. And the reason it's greater than or equal to is this word section right here. So it says at least. That means the smallest it could be is 30. So it can be 30 minutes, but it can't be any shorter. So that's why the greater than or equal to is the symbol to use for this. So the first thing we want to do is we want to simplify it. We want to simplify it so that we're solving for y. And so I'm just going to rewrite it. So 3x plus 5y is greater than or equal to 30. And then the goal is to get y by itself and positive on the left and everything else over on the right. So I'm going to subtract 3x from both sides. And then because 30 is positive, it's plus 30. Now, y is positive, but it's not alone. So I need to get rid of that 5. I'm going to divide everything by 5. And so y is now alone and positive. Bring down my symbol. And then because I cannot simplify 3/5, I'm going to rewrite negative 3/5 x. And 30 divided by 5 is positive 6, so it's plus 6. And this is going to be the equation that I am going to graph. Now remember, if I had written this as an equation, I know that this is my slope and this is my y-intercept. And I can use that information to graph on this grid. Now, one of the things I notice when I'm looking at my coordinate plane is that my numbers are going up by, my cubes are going up by 2's and sideways by 2. So it's counting by 2's. And 3/5 is going to be a little harder to do. I can do it, but I could make it easier if we take 3/5 and multiply it by 2, multiply that by 2, and then I get negative 6 over 10. And this is going to be much easier for finding my where my next point is. So my y-intercept is at 6, so I'm going to start at 6. And I'm going to use the slope of negative 6 over 10. So I'm going to go down by 2, 4, 6, and right by 10. 2, 4, 6, 8, 10. So this point right here. And then I'm going to draw my line right through there. Now, one of the things to remember is when we have greater than or equal to, or if we have less than or equal to, it's going to be a solid line. So when I drew this, I drew a solid line. If I had had greater than or less than, then it would be a dashed or dotted line. So it would have been a dashed line. So a solid line, a dashed line. Because this is greater than or equal to, I used a solid line. Now I'm going to go ahead and put that line back in here so I can show you. Remember before we said that ordered pairs can make it true? Well, ordered pairs are not only found on that line. Ordered pairs could also be found elsewhere in the grid that makes that statement true. So what we're going to do is we're going to find out which side we're going to shade. Are we going to shade the lower half, or are we going to shade the upper half? Okay, so one way to do that is to take any points in here. So say I do 0, 0, the origin. If I choose this point and it makes the statement true, then I'm going to shade the bottom portion. If I take another point, say at 8, 8, and I try that in my equation, and that is true, then I'm going to shade the top half. So I need to know which one I'm going to shade. So the first thing we do is we just try that ordered pair. And remember, the ordered pair has an X and a Y in it, doesn't it? So 0, 0, the point 0, 0 is below the line. And I am going to take and replace the X and the Y with my ordered pair 0, 0. Okay? So 3 times 0 is 0, and 5 times 0 is 0. And if I take 0 plus 0, do I get 30? No, I don't. It's less than 30. It's not greater than 30. So because it's less than, it's not greater than, this is a false statement. So that means that 0, 0 is not a solution. Now let's try my point 8, 8, 8. And it is above the line. And again, I'm just going to plug in my X and my Y for my ordered pair. And they don't have to be the same. It just happened that this one is. I could have used this point right here. It doesn't matter. So I have 3 times 8, and that's 24. And I have 5 times 8, and that's 40. That's 64. Is 64 greater than or equal to 30? Yes, it's definitely greater than 30, isn't it? So this is a true statement. What this is telling me is that I am going to shade above the line. So I'm going to get my highlighter here, and it doesn't have to be perfect. Just shade in to know, so you know which side of the line you can find the ordered pairs that make the solution. Okay? All right, let's go to the next one. They want us to graph negative 14 plus 2y is less than negative x by hand. So the first thing we're going to do is we're going to solve for y. We're going to simplify it, make it easy to graph. All right, so I'm going to move my 14 over to the other side because I want to get y by itself and positive. So I'm going to add 14 to both sides. And then I'm going to divide everything by 2 because I want to get that y by itself. And so y is going to be less than or equal to negative 1/2, because there's a 1 right here, x plus, and 14 divided by 2 is 7. So there's my equation that I'm going to use to graph, okay, or my inequality. Now, because I have, actually, I changed I need to fix that. Those were just less than. They were not less than or greater than. Because it's less than, this is telling me it's going to be a dashed or dotted line. Okay? So I have y is less than negative 1/2 x plus 7, and I'm going to graph it in this graph. And I want to determine if it's going. We know it's a dashed line. We just need to start with our y-intercept is at 7. It's going down 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2. I did several of them because it is partway through and I wanted to make sure it had at least 2 that were on the corners. Now we said that this was a dashed line, so when I pick my line this time, I'm going to pick my dashed line, and then I am just going to go through those 2 or 3 points. And what this means is that on that line, not every place on that line, not every point on that line is going to be an ordered pair, only some. So at 0, 7 would work, and at 6, 4 would work, because those we found when we were finding 2 points to draw the line. Now we have to determine which side are we going to shade. Are we going to shade the side that has the origin, or are we going to shade the side that has the 8, 8, which would be this one right here. So we're going to start with the origin, and we have, we're placing x and y with 0. So I have negative 14 plus 0, which is negative 14. And is negative 14 less than 0? It sure is. This is true. And this is below. If I did 8, 8, this would be negative 14 plus 16, which is 2. Is 2 less than negative 8? Nope, 2 is greater than negative 8. And so this is a false. So we want to shade below this line on this in this case. So we're going to shade below. So anywhere below this line, if I can find a point, it'll be a solution. So I found negative 2, 4. So ordered pair negative 2 and 4. If I plug it in for x and y, so I have 4 is less than negative 1/2 times 2 plus 4, or sorry, plus 7. That's negative 1 plus 7, which is 6. Is 4 less than 6? Yes, it is. So even if I take any point down here and try it, I can prove that I've shaded the correct place. So we're going to graph these inequalities. Our first one is 3 minus y is less than negative 5x. I see that it's less than. And remember, less is dashed. I'm going to reorganize it so that I have y by itself and positive on the left. So I have 3 minus y is less than negative 5x. I'm going to add 3 to both sides. Or sorry, subtract 3 from both sides. And then I want to make sure that I don't lose this, because once I move that 3, that becomes a negative. So it's negative y is less than negative 5x minus 3. I need to get rid of this, so I'm going to divide by negative 1. And I want to be careful. I am dividing by a negative 1. And if you'll remember, when we divide by a multiply or divide by a negative, the inequality symbol is going to change. So it's going to be y is greater than negative 5 divided by negative 1 is positive 5. And negative 3 divided by negative 1 is positive 3. So this is what I'm going to graph. Again, my graph is going by 2's. I can leave it at 5 for my slope, or I can take the 5 and multiply it, put it over 1 and multiply it by 2 over 2, which is 1, and that becomes 10 over 2, and that might make it easier to graph. We're going to start at 3. So here at 3, I'm going up 5. 1, 2, 3, 4, 5, and then I'm going right 1. So that's a positive 5, just so I have a nice straight line. I'm actually going to go down as well. So remember, we said it was going to be a dashed line. So when I draw my line, I want to make sure that it's not solid. And there's our line. Now we have to decide, are we shading the left side of the line or are we shading the right side of the line? This is called the upper side. This is called the bottom side. Okay, so I'm going to use the point 0, 0, and this is my most common one I like to use because it's the easiest one to use. So I'm going to take and replace my y with 0, and I'm going to replace my x with 0. So 3 minus 0 is 3, and negative 5 times 0 is 0. Is positive 3 less than 0? No, it is not. This is a false statement, which means that the origin is not a solution, will not work. So that means that I am going to be shading above the line, or in this case, to the left of the line. Okay, take a look at the next one. It is less than, so that means that the line is going to be dashed. I want to take and I want to rearrange it so that y is by itself and positive. So go ahead and solve so that you get y by itself. So when I solve to get y by itself, I get y is less than negative 5/4 x plus 8. So I find my slope, I find my y-intercept, and then I'm going to graph my line. And remember that we said that the line was going to be dashed. So go ahead and do that on your paper. Okay, you should have a line that's very similar to mine. And once you have that, now you have to determine which side of the line are you going to shade. Are you going to shade the bottom or the top? So use the ordered pair of 0, 0 to determine if the origin is a solution to this inequality statement. Okay, so what I did is I used the origin and put it in for x and y. And when I got done, I got 0 is less than 64. This is a true statement, so it's true, which means the origin is a solution to this inequality statement, and so I shaded in below the line. Okay, if you have any questions, please make sure you talk to your teacher.